Today we're going to chat about our introduction to graphing unit. Let's first start off by talking about how we plot points in a plane. X and Y are what we describe as an ordered pair. The first variable is the x. This indicates the point's horizontal location with respect to the y-axis, and the second number is y, which indicates the point's vertical location with respect to the x-axis. We call the first point the first coordinate the x-coordinate, and we call the second coordinate the y-coordinate. Let's graph and label the following points. So first I'm going to label them A through H. And then we need to talk about the plane itself. The plane has 4 quadrants that are split by the x-axis and the y-axis. We have our first quadrant, which starts in the top right corner, and we move counterclockwise to the second quadrant, third, and fourth. When we plot points, we first want to go left and right first using the x-coordinate, and then up and down using the y-coordinate. So if I want to plot point A, I'm going to start at the origin and I'm going to move left 3 units and up 5 units. If I want to plot the point 4, 3, I will go to the right, starting at the origin. I will move to the right 4 units and I will go up 3 units. To plot point C, I'll start at the origin, move right 3 units, and this time up 4 units. Take a moment to pause the video, and I want you to finish plotting the points D through H. Notice how H is the point 0, 0, which is also known as the origin. Let's determine whether each of the ordered pairs is a solution of the equation 2x plus 3y is 18. If this point is a solution, that means if we were to graph the line, this point would be on that line, and it would also create a true statement. Notice that -5 is my x value and 7 is my y value. We will substitute in -5 where we see x and 7 where we see y, and determine if it makes an equivalent statement on the left and the right. Well, 2 times -5 is -10, and 3 times 7 is 21. When I add them together, we get -11. And I know that -11 does not equal 18. This is a false statement. Therefore, since it's false, I know that -5, 7 is not a solution to the equation. Why don't you try part B? Pause the video and see if 3, 4 is a solution. I will plug in 3 for x and 4 for y, giving me 6 plus 12, which is 18. This gives me a true statement, so therefore I know 3, 4 is a solution. Another way to graph outside of plotting points is our x and our y intercepts. The x-intercept is a point, A, 0. This means that my point is on the x-axis. So if I am on the x-axis, notice that we're just moving left or right, so I'll just have a number. I'm not moving up or down, so that is why our y value is 0. My y-intercept, vice versa, our y-intercept is on the y-axis, so we are not moving left or right, which is why our x-coordinate is 0, but we are moving up or down for our b value. Let's find the y-intercept given our equation 2x plus 3y is 18, the same equation we used on the previous slide. I know that if I'm finding the y-intercept, that my x value is 0. When I substitute 0 in for my x value, we get 2 times 0 plus 3y is 18. Or 0 plus 3y is 18. We know that that means nothing, it just disappears, a placeholder. Divide both sides by 3, so y is equal to 6. My point then is 0, 6, and I can plot that point on my graph. To find the x-intercept, we will replace or substitute 0 in for our y value and solve for x. So 2x plus 3 times 0 gives us 18. We know that 3 times 0 is 0, and adding 0 just keeps it the same, so 2x is 18. Divide both sides by 2, and we get x is equal to 9. So our x-intercept is the point 9, 0. Now great, we have 2 points, but it's always great to find a third point to make sure we know exactly what our equation is going to look like. So to find a third point, I randomly picked the number 5, which is my x value. So I can find my y value by plugging in 5 wherever I see x. So 2 times 5 is 10, plus 3y is 18. When I subtract 10 from both sides, we end up with 3y is 8. Divide both sides by 3, so y is equal to 8 thirds, or that's the same as 2 and 2 thirds. When I put in 5 and 8 thirds into our graph, notice when I connect my points here, we create a nice straight line. If for some reason you end up with a squiggle line, something went wrong. We have to create nice straight lines in linear equations. Let's graph 3x minus 5y equal to negative 10 using a table of values. I have a table of values started down below, but what we're going to do first is solve for y, get y by itself. So to do that, what we're going to do is subtract 3x from both sides. That would leave me with negative 5y equals negative 3x minus 10. I now need to divide everything by negative 5. Negative 3 divided by negative 5 is positive 3/5, and negative 10 divided by negative 5 is positive 2. This is going to help me when I decide which values of x I'm going to choose in my table of values. I'm going to choose values of x which are easily divisible by 5 since I know my fraction is in fifths. So I chose negative 5, 0, and 5. What happens on the left, the middle, and on the right-hand side of my graph? Now when I plug in negative 5 to my equation, I have 3/5 times negative 5 plus 2. When I simplify 3/5 times negative 5, we end up with negative 3 plus 2, which is negative 1. Let's substitute 0 in for x. 3/5 times 0 plus 2 is 0 plus 2, or positive 2. And finally, let's plug in 5, or substitute 5 in for x. 3/5 times 5 plus 2. Here my 5's cancel, leaving us with 3 plus 2, or 5 itself. We now can fill in our table, and we have 3 values with which we can plot on our graph. I've plotted negative 5, negative 1, 0, 2, and the point 5, 5. Notice they create a nice straight line, and I use Desmos.com to help me. Let's graph y is equal to x squared minus 9x minus 12. I know that this is going to be a quadratic, so I'm going to end up with a smiley face or a frowny face parabola. Because of the x squared, that x squared tells me the shape of which our equation might look like. I've got ourselves a table of values here, but how do I substitute them in? I'm going to use x equals negative 3 to show us how we can do this. So when I use negative 3, I'm going to substitute negative 3 wherever I see x, giving us negative 3 squared. So negative 3 times negative 3 is positive 9. Negative 9 times negative 3 is positive 27. Minus 12 is 24 when we add them all together. So we have the coordinates negative 3, 24. Let's also do the same for a positive value. How will that affect our equation? So wherever we see x, we're going to substitute in 2. 2 squared minus 9 times 2 is 12. 2 squared is 4 minus 18 minus 12 is negative 26. So 226 is our graph. And I went ahead and used Desmos to plot our points. And notice that when we graph this, our points match up with what our table says. The distance formula. Sometimes we need to know how far it is from one point to another, and the distance formula can help us. The distance formula is our second x value minus our first x value squared plus our second y value minus our first y value squared. We find the sum of those two and take the square root. So when I look at my first example, negative 2 is my first x value, 3 is my second x value, 2 on the left is our first y value, and negative 6 is our second y value. Using the formula, we will take 3 minus negative 2, which is our first x value, and square, plus the quantity of negative 6 minus 2 squared. I know that a double negative turns to a positive, so 3 minus negative 2 is positive 5, and negative 6 minus 2 is negative 8. 5 squared, which is 25, and negative 8 times negative 8 is positive 64, gives us the square root of 89 in its exact form, or rounded about 9 4/10. Pause the video, see if you can fill in the blanks for the right-hand side. I do feel like I see an error over here. We're going to take negative 1 minus negative 1 squared plus 2 minus negative 5. So notice that if we're going to keep our second value first, we have to keep that consistent with what we're working with. So negative 1 minus negative 1 turns into negative 1 plus 1, which is 0, plus 2 minus 5, which is positive 7, gives us 0 squared plus 7 squared, or 49, and the square root of 49 is 7. The point negative 2, 5 is on a circle that has 3 negative 1 at its center. Find the length of the radius of the circle. So in decimals, I put just our 2 points here. Negative 2, 5 is on the circle, so it's going around, and this piece here would be our center. So if we can envision this circle going all the way around our center, we know then from these 2 points would be our radius of the circle. We need to find the distance between these 2 points to find the length of the radius. Using the distance formula then, I'm going to take negative 2 minus 3 plus 5 minus negative 1. But you're saying, but you just told us on the last slide that it has to be consistent. So notice this time, instead of we're taking our x2 value first, I'm taking my x1 minus x2, y1 minus y2. So as long as you're consistent with which you take the order, everything is fine. Negative 2 minus 3 is negative 5 squared, plus 5 minus negative 1 turns into a positive 6 squared, giving us then 25 plus 36, or the square root of 61, which is approximately 7 8/10. Sometimes we want to know what the midpoint is. So the midpoint formula tells us if we have 2 points, we can add our x values together and divide in half, add our y values and divide by half. Find the midpoint of the segment between negative 4, negative 2, and 2, 5. I'm going to add my x values together, giving me negative 4 plus 2, and our y values together, negative 2 plus 5, each piece divided by 2. So negative 2 halves, 3 halves, which can simplify to negative 1 3 halves. And I've added that piece in there. We can see it is halfway between. Find the diameter of a circle that contains the points 2, negative 3, and 6, 4 on the circle. What we need to do then is find the midpoint. If we know that the diameter connects these points, we can find the center because the center would be in the middle of the circle when I go from one side to the other. Therefore, I can take 2 plus 6 and negative 3 plus 4, both coordinates divided by 2, or 8 halves, which is 4, and 1 half, which simplifies to half itself. All this talk about circles certainly leads us to the equation of a circle. The standard form of the equation of a circle with a center hk and a radius r is given by the formula. I'm taking x minus my x value of my circle, the center of the circle, plus y minus the y value of the center of my circle. Each piece is squared, equals to the radius squared. So it's asking us to find the equation of the circle if we have a radius of 5 and a center of 3, negative 7. So my h value is my 3. My k value is my -7, and my r value, it tells us our radius is 5. Now we need to simply substitute into the standard form of the equation. X minus our h value, y minus our k value, each piece is squared and added together, is equal to our radius squared. At this point, we just need to simplify. Nothing to simplify with x minus 1 squared, plus the quantity of y minus -7, which we know can simplify to y plus 7 squared, equals 5 squared, which is 25. And here I have our circle. We have 3, -7 as the center. And if I count 1, 2, 3, 4, 5, I see that we certainly do have an equation. I put this full equation into Desmos just to make sure that it matched. Let's graph the circle x plus 5 squared plus y minus 2 squared is 16. Thinking about what our standard form looks like, I can pull information from this equation. I can rewrite x plus 5 in subtraction form by saying x minus -5 plus y minus 2 is equal to 4 squared. Now I know that -5 is my h value, 2 is my k value, and 4 is my radius. Using Desmos then, I was easily able to graph this by starting by plotting my center at -5, 2, and counting 4 units in each direction and connecting the dots. And this time I used Desmos, and I encourage you to do the same. We will graph the circle on the graphing calculator using Desmos.com. To do this, we need to know the center and the radius of the circle. So we have our equation of x minus 2 squared plus y plus 1 squared equals 16. Let's write it in standard form first. We'll have x minus 2 plus y minus a -1, so that we get the subtraction piece in our standard form, is equal to 4 squared, because 4 squared is 16. I now know that my center is at +2, -1, and that my radius is 4. Using Desmos to help us, I can graph our equation, and I see that our center is at 2, -1, and that the radius, when we count 1, 2, 3, 4 units, gives me each direction. And this concludes our first lesson on graphing.